All right. I'm pretty sure I'm in business here. All right, y'all ready? Everyone ready? We have a lot to do today. Um, I'm going to save answering any questions over the homework right now, just so we can get through these rational functions. I passed around a handout. Anyone not get this handout? Okay, so you know on your exams you're allowed to have a cheat sheet, right? Okay, this you can have in addition to that cheat sheet. So it's basically the steps for sketching polynomial functions and rational functions. It does not have quadratics, so you'd have to put that on your cheat sheet. The steps you can see for sketching rational functions is somewhat like what I covered last time, but we never finished the problem, so we need to go finish that problem that we were doing at the end of class on Tuesday. Yes? Well, you can write on your cheat sheet. Don't write on the back of this. So cheat sheet front and back, but don't write on this. You're trying to get 3 sheets out of me, aren't you? Okay, this was the function that we were doing, right? It was x over 1 minus x, right? I want to revisit that now that we have the steps and kind of walk through it slowly, and then we'll do another problem that's going to be, well, it'll be a lot more challenging. So f of x equals x over, what was it, 1 minus x? Yes. It was? Yes, 1 minus x, okay. All right, so the first thing we do is we realize we have a rational function, right? Looks like a fraction. So step A here on this sheet, that's what I'm going to go off from now on. Step A for sketching rational functions is to completely factor the numerator and denominator. So what do you think about that step? It's done, right? It is done because it's factored. You can't factor x and you can't factor 1 minus x, so we're done. Step B, cancel any common factors and keep note that you will have holes at the points which make those cancel factors equal 0. Well, we never canceled anything because we never had any factors that canceled top and bottom. All right, so I'm going to put check here because we don't have to do anything. Step C is to find the x-intercepts, and it even says here how to do it. Set the numerator equal to 0 and solve. So we set the numerator equal to 0, and when we do that, we already have the answer, don't we? X is 0. Now I'm going to box this, and next to it I'm going to write down what it is again. That's an x-intercept. So this is a point, just to remind you, on the x-axis. Right? That's what it is. When I go to graph it, it's going to be a point that I put on the x-axis. Step D. Find the vertical asymptotes. How do you find the vertical asymptotes? Set denominator equal to 0, right? So I take my denominator, set it equal to 0, solve. So add x to both sides. X is 1. Now next to this, I'm going to put what that represents on our graph, and I'm doing a different color. One is a vertical asymptote. Remember, the vertical asymptotes are those barriers, right? Vertical barriers. So this is going to be a vertical dotted line. Right? It's a barrier. And what does it do to our function? You want to remember? As our function gets closer to that dotted line, what does it do? It either goes up or down forever. Barrier forces our function, I'll just call it f, up or down. Agreed? That's what happens. We saw that last class. Step E, find your horizontal asymptotes. Now, the way I have this written here, case 1, 2, 3, may be a little different than what I did in class. I don't recall how I did the cases. I think it's right. I think it matches what we did in class. But for officially, this is what we'll call case 1, 2, and 3. So we have to find horizontal asymptotes, we have to look at the degree of the numerator and denominator. In this case, what's the degree of the numerator? 1. Highest power of x, 1. Degree of denominator? Same thing? 1. Right? So our degrees are up there, 1 and 1. So now we need to compare them. Either one of them is bigger than the other, or one is smaller than the other, or they're the same. So we are case 3, aren't we? Case 3, they are equal. So I'm going to put here case 3. And according to this, it says that y equals LC numerator over LC denominator. And we said LC stood for what? Leading coefficient. So let me go back up to my function. What was the leading coefficient of the numerator? 1. There it is. Right? That's 1. And then what's the leading coefficient of the denominator? -1. Good. So therefore, if we take 1 and divide it by -1, we get -1. Now, just so you know, and we're going to do today after this, we're going to do 3 rational functions. That's the goal for today. And each one of them is going to be different on this step E. So I'm going to give you one that's a case 1, and then a case 2, and a case 3. That way you can see the difference between all those, all right? Because that's really the main difference with rational functions, is what's happening with that horizontal. Okay, questions on that? Now let's talk about what this is geometrically on our graph. It is not a horizontal barrier. It is a horizontal dotted, right? Dotted line. That's what I'm going to draw. But I told you to only draw it where? Drawn at the ends only. So we'll be drawing a dotted line just at the edges at y equals -1. Wherever, y is up and down. So we'll actually go down 1 and we'll draw dotted lines at the edges. Right? But what does it do to our function? Like the vertical asymptote part D, that dotted line we draw, it forces our function up or down. Do y'all remember what the horizontal dotted lines at the edges does? How it behaves? What it does to your function? Okay, but if I have a dotted line drawn like this, let's just say, my function can't do this. What does it have to do? It has to go towards the dotted line, right? So I said treat it like a magnet. It draws your function towards it, right? So let's keep that in mind when we are doing this. It pulls function towards it. Toward it. Like a magnet. And I'll put here ... ends only. I can't stress that enough. It only tells you about what's happening at the ends. All right. We are done gathering information at this point, and now it's time to go into part F, which is to plot the information. That's supposed to say from parts A through E, not C. That's a typo. I've had this document since 2005, and I just haven't even updated it. So, got it? I'm going to put everything down. Let's see what we get. So I'm going to start a new page. Go ahead and throw a little graph in here. Nope, don't want that. All right, you ready? Here we go. What is the first piece of information I I gathered? What's the first thing I know about my graph? The x-intercepts, right? I have an x-intercept where? At 0. So I'm going to go to 0. I'm going to draw a dot. Okay, that's the first thing. Next thing, I have a vertical asymptote. I did that in green, right? I did that in green, so I'll do it at where? -1, right? It was at 1. Okay, that's right. So at 1, I have a vertical asymptote, so I'll draw it like this. It's kind of weird because it looks like my 1 is part of my vertical asymptote. There, I'll do it like that. Agree with that? What is the next piece of information? A horizontal asymptote at -1. Y equals -1. So that means I'm going to drop down 1. There's -1. And I will draw, I draw a dotted line, but only at the end. So I'm going to just come out here to the right side and just start drawing a dotted line toward the end like this. And then out the left side, same thing. That's what I know so far. Now, do you remember when we were doing polynomial functions and we knew like left and right behavior, and then we found the x-intercepts? And then that wasn't enough for us to be able to graph it because we didn't know about that crossing and bouncing. Do y'all remember that? Yep. Before we knew about crossing and bouncing, we had some information, but we didn't have enough. Then we got cross and bounce, and we were able to get everything. The same thing applies here. We have a lot of information to graph, but we don't have enough. So we have to do one more thing to be able to be very sure about what this looks like. And that is part G. Part G says find test points. That means what I'm going to do is I'm going to pick a few points and I'm going to test them by plugging them into the function and actually plotting them and figuring out where they are. But the points you pick are not just arbitrary random points. They have to be very specific, I guess is the word I'm looking for. I don't know. That doesn't sound right. They have to follow this format that's in part G. It says find points between and on each side of both the vertical asymptotes and the x-intercepts. What the hell does that mean? Well, I have how many x-intercepts here? No, how many? I have one x-intercept, right? How many vertical asymptotes do I have? 1, right? So together I have one x-intercept, one vertical asymptote. So together 2, right? I have 2 important things happening. Don't worry about the horizontal, just x-intercepts and vertical. I have a total of 2. That means you will need 3 test points. You always need one more test point than the total number of x-intercepts and vertical asymptotes put together. All right, so if we had 2 x-intercepts and 2 verticals, I'd need 5 test points. With me? The way you pick them, though, has to be correct. So I need 3 test points total, but I have to have one on each side and in between every vertical asymptote and every x-intercept I see. So let me... There's got to be one in here. I'm just going to highlight it green so you can see. I've got to have one there because isn't that between my x-intercept and my vertical? I've got to have one on each side also. So I've got to have something on the right side of that vertical and then something on the left side of that x-intercept. You see that by putting those marks there, I do now have a point between every x-intercept and vertical asymptote and on each side. Right? Now, what I pick is completely up to me and up to you. The numbers you actually pick. So I can pick any number I want, like this one over here on the left. I can pick anything I want on that side of the x-intercept. So I could pick -1, -2. I could pick -2.7563. Any number I want. But I recommend you pick a number that would probably be easy to plug into the function. So something like maybe -1, right? How about something between that x-intercept and that vertical asymptote? 0.5 or 1/2 or 1/4 or anything you want. 0.1 would work. It's just got to be between those 2. And then on the right side of 1, 2. 10, a million, doesn't matter. Just has to be to the right side. Make sense? Okay, so I'm going to get rid of all this junk here, and I'm going to show you the way I'll do it. What I do is when I pick my point, I put a little X through it, okay? I don't recommend you put a dot, because if you put a dot, you might think that's part of your graph later. I put a little X, and I say -1, that's going to be my test point there. Put a little X in here, and then maybe 0.5, I'm going to put 1/2. And then an X over here, and 2. That okay? So my test points now, these have to be plugged into the function. So I'm going to be doing step G below the graph. Step G. My test points are as follows. -1, 1/2, and 2. And now I plug those into the function to see where I am, what the function spits out when I give those to the function. So I need to figure out what's f of -1. Remember the function was one at a time, yep. So remember the function, I'll write it down here. It was x over 1 minus x, right? So plug -1 into that, you get -1 over 1 minus -1. Be careful there, that's not going to be 0. Right? It's going to be what? -1 over 2. -1 over 2. -1/2. Minus a minus is plus. All right, let's plug in 1/2. I'll do it right next to this. That means I have 1/2 over 1 minus a half. That's 1/2 over, well, if you have 1 and you take away half, you have half, don't you? And 1/2 divided by a half is 1. Now, at any point, you're allowed to use your calculator. Okay, these functions will become more complicated. So just understand that I expect that everyone can plug a number into a function at this point, right, and get the correct answer. And then the next test point would be what? 2. So 2 over 1 minus 2 is 2 over -1, which is -2. Questions? Now I'm ready to go and plug these 3 points in, these test points. That means plot them, because they're part of my graph. So let's go back up and plot these. First of all, at -1, where am I? -1/2. So I go to the left 1 and down 1/2, which is about right here. At 1/2, where am I? At 1. So I go right 1/2 and go up 1, which would put me about here. And then at 2, I was at, where? 2, I'm at -2. So down 2 would put me about here. Do y'all agree? That's it? Any questions? Okay. Now, according to the steps, the steps, we are done. It's just a matter of sketching now. We just have to draw it. Now, I put here at the bottom of the page for step H, sketch it. I say, remember, you cannot cross a vertical asymptote. Horizontal asymptotes are like magnets that pull your function toward at the ends of your graph only. And you can only cross the x-axis at your zeros. That's a big one. You can only cross the x-axis at your zeros. So when I go to draw this function, what I have to keep in mind is I should be able to draw a nice curve. Okay, I should be able to use my pencil to draw a nice curve. Now, the vertical asymptote may block me, and I might have to pick up my pencil and actually go to the other side of that vertical asymptote and continue drawing. But anywhere there's not a vertical, I should be able to just use my pencil and draw, right? It shouldn't be some crazy thing like this. My graph shouldn't look like this and then come down here and go like that and then do this and then come wrapping around like that. I mean, it should be nice and smooth. Understand? Should be. That we need that to be able to draw it. So here's where I start my drawing. I always go to the furthest point to the left that I know exists on my graph, which I just highlighted yellow. That point, right, exists on my graph. I know for sure. And if I'm going to draw through that point, then that means I have to draw it to the left of that point and to the right of that point. Agreed? So you could almost imagine it like this. I have to come out the left side of that point. I have to come out the right side, don't I? All right, now let's think about what would happen if I come out the left side. What has to happen when I come out the left side? I have to go towards the magnet, right? And when I come out the right side, what has to happen? Yes, it does have to go up, but the reason it has to go up is because it has to get from this point to this point, okay? This is like, I don't want to make it sound like this is easy, but this is almost kindergarten at this point. It's connect the dots. And what you're looking for is anything that might get in your way, right, would stop you from connecting the dots. So let me get rid of that little yellow. Oh, I killed the whole dot there. Is it there? So as I come out the left side of this, I'm going to go down towards my magnet like this. That's pretty good. And then I'm going to curve up and I'm going to go to that next point right here. Now, same story. That point that I just went to, I already know what happens out the left side because I just came into it, didn't I? But what about going to the right side? It has to go up and hit that next dot. So then I come up and I hit that next dot. Now you can already tell what's going to happen, right? Kind of, right? When I try and come out the right side of this dot like this, I can't cross through like that, can I? That vertical asymptote forces me to either go up or down, doesn't it? Someone tell me why it doesn't just dive down. Why can it not do that? It's not because it doesn't look like it's going to do that. There's something. If I draw that blue, that's right, good. If I drew the blue, I would cross the x-axis again, wouldn't I? Right here. I would basically be creating an x-intercept that does not exist on the graph. Wouldn't I? So it cannot turn back down. Therefore, it must go up. So it's not this thing of, oh, that's what it looks like it does. That's what it has to do. Does that make sense? Okay. Uh-oh. There. So I will go and curve up like that. I didn't have coffee this morning. Maybe that's why my hands are steady. I'm like a surgeon up here. It's not by choice. I was running late this morning. Okay, that all makes sense? So we basically have the left side of the graph done. The only way to get to the right side is to actually pick up our pencil and jump over the graph. And when I do that, I need to go find the next point that I know exists, which is this one, right? Now, from that point here, I must come out the left. I must come out the left, and I must come out the right. So what's going to happen when I come out the left? I'm going to be sitting here going, which way do I go? Right? Up or down, up or down, up or down? Right? It has to go down, right? Can't go up because you would create an x-intercept, wouldn't you? You can't do this because, boom, right there you would have that x-intercept, and we don't have one. Okay? So let me draw this and curve it down like this. And then to the right, coming out that point, what has to happen? It's got to go up to that dotted line. That's it. Now, does everyone remember the vertical line test? Do I remember the vertical line test?
Yes.
It's the test that you did to check whether or not something was a function. You might remember it this way. If I give you a graph and I said, hey, everyone, is that a function? Is a parabola a function?
Yes.
You'd say yes, right? Because it passed the vertical line test. But if I drew something like this and said, is that a function? You would say, no, because if I draw a vertical line here, I hit it actually 1, 2, 3 times, don't I? Vertical line test tells you, you draw a vertical line, you can only hit your graph 1 time, right? Keep that in mind. When you are done drawing rational functions, it has to pass the vertical line test. I tell you that because students will draw things and I'll be like, what were they thinking? Like it doesn't even pass the vertical line test. It has to. So I look at this at the end, check it, vertical line test, I'm good. It's a function. Pretty exciting. Pretty exciting. Uh-oh, what did I do? Not responding. You're right. Close the program. All right, here we go. New problem. As you can see, these take a while, don't they? All right, let's try this one. We're going to try and sketch the function f of x equals x squared plus 4x minus 12 divided by 2x squared minus 32. Now we're getting into some test level problems. That first example we did was just to get us warmed up with the ideas and with the technique. All right, let's follow the process. Step A, completely factor the numerator and denominator of the function. Well, this time I have to factor. And this is not even going to be something I show how I do it. I would expect that everyone could get to x plus 6, x minus 2 over. Now on the bottom one, I will help you. Pull out a 2 first. If you pull out a 2 on the bottom, GCF, then the x squared minus 16 is a difference of squares. So I get 2 times x plus 4 times x minus 4. I hope you feel like you could do that. Everyone understand what I did? Okay, part B, cancel any factors, common factors. So what they mean by this is like if I had an x minus 2 on the top and the bottom, I could cancel them here. I don't have that, so I'm not going to do it. But that's what step B would be. All right? And then we would have a hole in the graph. I usually don't do that. I never give students functions that have holes in them. But this process, the steps, I wanted them to be complete, so I included it in here. I wouldn't expect to see that on a test. So on this step, I'm just going to put a check mark next to it as in everything that's canceled. If it could be canceled, is canceled. What's next step? X-intercepts, right? So set the numerator equal to 0. Now, I actually have 2 numerators. I have the one that's not factored, and I have the one that is factored. So if I'm going to set one of them equal to 0, I may as well set the one that's factored equal to 0, right? So I'm going to set x plus 6, x minus 2 equal to 0. Set both to 0, you get negative 6 and positive 2. And these, again, remember, are what on our graph? X-intercepts. They're dots on the x-axis. I'm not going to write all that, but let's just keep it in mind. Step D. Now I'm going to find the verticals. So for the verticals, I set the denominator equal to 0, which again, I should probably do the factored one. What about that 2 out front? That's right. Do not put 2 as one of your answers. Because all you're really doing here is you could divide both sides by 2, and that 2 is like it was never there. Okay, so I don't want to put all that on there, but just ignore that 2 out front. The x plus 4 and the x minus 4, yes, you do have control over that. If x is negative 4 or positive 4, that will be 0. So 2 solutions are negative 4 and positive 4. Those are verticals. So we have 2 x-intercepts and 2 verticals, don't we? All right, step E, our horizontals. So let's go back up here and take a look at our function. And I'm going to look at the one before we factored it, because that makes it easy for us to find the degrees. The degree of the numerator and denominator are the same again, aren't they? So we are in case 3 again. Because they're the same, what is it that we look at to figure out our horizontal? The number in front of each. So I have a 1 in front there, and here I have a 2. So y equals 1 over 2 is my horizontal asymptote. And that is just, y is 1/2. That means in the last problem, y was negative 1, so we came down 1 and we drew our dotted lines at the edges. Here we'll go up 1/2 and draw it out on the edges. Questions on where I got the 1/2? You're not going to admit it to me, but I know this is fun. I mean, I know. It's okay. I can tell. I mean, I can just tell by looking at everyone. It's fun. Laughter is denial. All right, here we go. Step F, plot the information. All right, so we have x-intercepts where? Negative 6 and 2. So 1, 2, 3, 4, 5, 6. Negative 6, 1, 2, positive 2. Ooh. Everyone agree? What's the next piece of information? Verticals, where are they? Negative 4 and 4. 3, 4. There's 4. Negative 4 is here. So these are dotted lines. I again would urge you to be cautious on these verticals. I've seen students do this in the past. They'll put a dot there. They'll put a dot there where the vertical occurs. I would not ever put dots on the x-axis unless they're your x-intercepts, because that can confuse you later. You may think you go through that dot, especially if you're not writing in 4 different colors like I am, right? Always just take that dotted line right through the number, 4 and negative 4, and that's it. That okay? What's next? Horizontal, and that's what? 1/2? So if 1 is up like that, that's about 1, let's say. Half would be halfway, and I'm going to go out to the edges only and draw a dotted line. And when we say edges, you just have to go far enough where you don't have any other information out there. Like I wouldn't want to say that the edge is right in here before my vertical. It's past that somewhere. And then on the other side, same thing. That's almost enough to draw it. I just need one more, well, not one more thing. I need some more things, but test points. So someone tell me how many test points I should have. 5, right? 2 x-intercepts, 2 verticals, 5 total. So I need to pick one to the left of -6. So how about -7? Something between where and where? I'll highlight these so you can see where my test points are. Okay, so how about -5? How about the next one? Where should I pick one? Between where and where? Missing one. Hold on. I'm moving from left to right. So between -4 and 2. Anything I want between -4 and 2. 1, 0, any of those. I like 0. 0 is always a nice number to plug into a function, right? Because it kills a bunch of stuff off. So my next test point here is 0. Then between 2 and 4, so 3. And then finally 5 or 6, doesn't matter. Here's 5. I'll do 6. And you have to do what with these? Plug them into the function. Oh, doesn't that sound like fun? Now, I would like to show you a shortcut. But I mean, it's not going to be that short, all right? It's just saves you a little bit of time. By the way, notice how in this problem you were able to pick a test point that was an integer. Like in the previous problem, we had an x-intercept at 0 and then a vertical at 1, which forced us to pick a 1/2 or something like that. Notice how this problem worked out where you always had a nice number between them. That's the way I designed the problem. And on a test, I'll always make sure that you have a nice integer to pull between any x-intercepts and verticals. So you're not messing with the fractions. All right, no problem. Okay, so let me write the test points we're going to have first. This is step G. We're going to test the following points: -7, -5, 0, 3, and 6. Now we are going to test them into the function. Now we have 2 options. I'm going to write the function down next to this. We have the original function before we factored it, which was x squared plus 4x minus 12 over 2x squared minus 32. So we could plug our values into that if we so desired, or we could also plug it in to the factored one. Yeah, the factored one makes life a little easier. 2x minus 4, x plus 4. Now let me show you how this will work. I like to plug into the second one. I find it goes a little quicker. So here we go. Let me try -7. The way you look at this, when you're looking at it in the factored form, you look at it like you have 1, 2, 3, 4 numbers you have to figure out, right? First one is this one, top left, x minus 2. What is -7 minus 2? -9. You're going to multiply that times whatever you get when you plug -7 in to the top right. -7 plus 6 is -1. And then over, let's see, the 2's sitting out here. Don't forget that 2 that's in front of the x minus 4. You plug -7 in. What's -7 minus 4? -11. And then -7 plus 4 is -3. Is that all right? I feel like I lost a bunch of you there. This one was -7 minus 2. This was -7 plus 6. This was negative 7 minus 4. And this was negative 7 plus 4. Everyone see where those numbers come from? Now just multiply straight across. Negative 9 times negative 1 is 9 over, let's see, negative 22 times negative 3, 66, which is a number you're not going to have an easy time graphing, right? So just get your calculator out and do 9 divided by 66. It's 0.136. I'll just say approximately 0.14. That okay? And yes, you now have to test all the other points the same way. So there's 4 more to go. But do you understand what you're doing? Let me plug in negative 5 now. Yeah, negative 5. F of negative 5. I'll do this a little quicker. Negative 5 minus 2 is negative 7. Negative 5 plus 6 is 1. 2, and then negative 5 minus 4 is negative 9. Negative 5 plus 4 is negative 1. So I get negative 7 over 18, which is approximately, again, I get on my calculator, 7 divided by 18, well, negative 7. Negative 0.39. So I'm rounding like 2 decimal places. Now check out the next one when I plug 0 in. Check out when I plug in 0. I'm actually, for 0, I'm going to plug it in. Whoa. For 0, I'm going to plug it into the top, the top function. This one here in blue. The reason why is because if I plug 0 into that one instead of the bottom one, I kill off the x squared and the 4x on top, right? Which leaves me with just negative 12, and then on the bottom, negative 32. See how clean it is to plug 0 into the top one? So I'll do it that way. And you have, options here, whichever way you want to go. Negative 12 over negative 32. .38. I'm rounding again. And it's positive. How many more? 2 more? F of 3. For 3, I'll plug into the bottom one. It's 1 times 9 over 2 times negative 1 times 7. So 9 over negative 14 equals approximately negative 0.64. One more, and we're ready. Yep, I told you. F of 6. So 4 times 12 over 2 times 2 times 10. Change my notation there on 6 using dots instead of parentheses. 48 over 40. Right? 1.2. You all right? Tired? Yeah. I was so tired on Monday. Yes. Setting denominator equal to 0. So we took 2x squared minus 36, which had been factored, and it was 2 times x plus 4 times x minus 4 right here, this bottom part. Setting each of those to 0, yeah. That's how you get your x-intercepts. You set the top to 0. Yeah. I'm sorry?
So that would just
Be 1. Set x minus 2 times x plus 6 to 0. The factored one, you set each factor to 0. We did it. It was step C. Step C. Okay, let's go. We're ready to graph. Let's do it. We still got 2 more to go. I don't think we're going to be able to do it. At -7, where are we? 0.14. Right? At -7, we're at 0.14, which puts us real close to the x-axis. Right about there. Where are we at -5? 0.39. So I don't want to draw on top of my own stuff. I'm just going to put... The main thing is that it's negative, so it's down a little bit, right? All right. At 0, where are we? 0.38, so that's up a little bit. At 3, we were at -0.64, so I'm going to just put it below somewhere. And then at 6, finally, we were at 1.2, which moves me up here somewhere. You kind of have that? What I would recommend you do is when you go to draw these, take up a lot of space on your page, make it real big so you can get everything in there. All right, that should be everything we need. Start at the leftmost point. Point all the way on the left. You have to go out the left side of that point. So what are you going to do out the left side? Go towards that blue dotted line. Okay, there we go. What happens now? From that dot, I go to the next dot, right? There's nothing in my way. And that's my x-intercept, so I connect it there. And then from that dot, where? Down, right? So I'm actually crossing through the x-axis here to this dot. And then that dot to the right, what happens? Vertical barrier, right? That vertical barrier now forces my function down forever. Now, once you get to a vertical barrier, that's it. You have to kind of pick up your pencil, go to the other side, find the first point that you have, which is the one right there at 0.
Yeah, I know you're going to get to this, but I got a quick question.
Yeah.
For your next one, you're going to start at the leftmost point, right?
This point right here is where we're going to start.
But you're going to go to the left, right?
I have to go to the left.
So it's in a fix, you have to curve upward.
That's right. That's right. When I try and come out the left side of this, eventually I have to make a decision to go up, or I would have to go down. But again, why can't I go down? I don't have an x-intercept there, right? And why can't I do this? Yeah, and just come back there.
Because you can only cross that x-intercept one time.
No, I won't pass the vertical line test. See, I won't be a function. So it can never go and turn back on itself. So that means I have to go out the left side, and I have to eventually go up forever like this. Now, what about the right side? Go to that x-intercept. That's where you cross, right? You cross through, go to that next point, and then when you get to that point, again, the vertical gets in my way, so it forces me down. I cannot come back up because there's no x-intercept there. Jump over to the next point, which is this one. Going out the left side, what has to happen? Has to go up, and going out the right side, it has to go towards the blue, right? So since I know that it's going to do that, I can draw it nice and curved so it doesn't look awkward. That's it.
Now, you're going to give us a shittier one.
Shittier isn't a way to describe it. No. This is pretty much it. I mean, there's nothing more to it. see if this opens for me this time. There we go. Oh, wait. It's not a polynomial. It is a rational function. Let's see. What was the degree of our numerator? 2, right? And it was, what were the roots of that? X. It was 2 and negative 6, right? 2 and negative 6. And the denominator had a degree of 2 also. And it was 4, negative 4. But there was a 2 in front here. Oh, you know you want that. Yeah, I didn't plug negative 4 in. That's why that graph doesn't look right. There we go. That's it. That's what we have, right? Now, this dotted line goes all the way through my horizontal because I wrote the program. It was too much of a pain in the ass to cut the middle of it out. That's just to verify we did it. The excitement continues. X squared plus 3x minus 18 over 2x plus 4. So what do y'all think? I mean, your next test, you're going to have to graph the quadratic functions. That's the parabola, up, down, vertex, all that. You're going to have to do the polynomials, where you'll have to do the synthetic division. 4 or 5, yeah. I mean, I don't think, yeah, it might be 6 or 7. I don't know. It's usually one of these, one polynomial, and then 2 quadratics. That's usually what it is, about 4. They could. All right, well, let's see how long this takes. I'm going to work a little faster through this one. All right. First step, factor. So I factor out the numerator, x plus 6x minus 3. Factor out the denominator. I can just take a 2 out, that's it. Part B, check. I don't have any common factors. Part C, x-intercepts. What are my x-intercepts? Negative 6 and positive 3. How did I get my x-intercepts? Set numerator to 0. Good. Step D, find the vertical asymptotes. How do you do that? Set denominator to 0. What do you get if you set denominator to 0? X is negative 2. I'm not actually writing this out. Y'all understand what I'm doing? Okay, step E. Okay, what case do we have? The degree of the numerator is 2, right? Degree of denominator is 1. Therefore, the degree of the... What is what? Which one of these am I looking at? Which case? Case 2. The degree of the numerator is bigger than the degree of denominator. That means we have no horizontal asymptote, which means we have no magnet. We have no magnet. So our graph is never going to get pulled down to any line. So we'll see how that's going to affect the graph later. So I'm just going to put here no horizontal asymptote. Part F is to start drawing, right? Here we go. Oh. Why is it not doing that? There it goes. Okay, I'll start with my x-intercepts. My x-intercepts were at 3 and -6, right? Where's my vertical? -2. Hey, while I'm doing this, let me point something out. You may at some point get a problem where your vertical asymptote is at 0. Vertical. How would you draw a dotted line through your y-axis? That'd be kind of weird, right? You know what I'm saying? Here's the way students have done it in the past. I think it works good. Now, we don't have it here, but if we had a vertical line that we had to draw through the y-axis, I've seen students do the dashes as little diagonals like this. And that, if by doing it like that, you can still see the vertical barrier. Just something you might adopt that strategy if you get that to happen during a problem. All right, continuing. That's it, right? I don't have any horizontals, so I don't draw anything else. Test points. Where am I going to test? I'm going to have a total of 3 points. -7. -3. That'll work. 0. 0 is fine. And then 4. Wait, I thought you said we would only have 3. Okay. So we actually have how many? 4. Because we had 2 x-intercepts, 1 vertical. That's a total of 3. So 1 more than that is 4. So we'll have 4 test points. Those get plugged into the function. Now I'm going to plug it into the factored form of the function. So let me put the factored form up here. It was x minus 3, x plus 6 over 2 times x plus 2. All right, I'm going to try and do this, well, quickly. F of -7 would be -10 times -1 over 2 times -5. So 10 over -10, right? -1. -1. So -7, I'm going to go ahead and plot it now. At -7, I'm down 1. Now I plug in 3. -3, I mean. I get -6 times 3 over 2 times -1, which is -18 over -2. It's +9. So at 3, I'm up at 9. That kind of makes sense. It's a vertical barrier in my way. At 0, I should plug it into the other one, right? -18 over 4. Which is -9 over 2, which is -4.5. Somewhere around here. And finally at 4, I get 1 times 10 over 2 times 6. 10 over 12. It's 5/6. So a little less, a little more than a half. Doesn't matter. It's just somewhere above the x-axis. Is this all right? Any questions on where I got any of my test points plugging in or anything like that? You ready to draw? Start with your leftmost point. That one right there, that little point far left. You have to draw out the left side of that point and out the right side. So if I draw out the left side, what has to happen? We haven't had this happen yet, so I'm curious to see who's going to figure it out. What has to happen? Yes. Okay, where though? Like, yes, I agree, but how? Going down, just like this? Something like that? That seem reasonable that it would do that? Now, what it can't do is it can't go flatten out, okay? Because if it flattened out, I would have had a horizontal. So yeah, it's really going to act more like a polynomial. Remember our table, the 4 possibilities, left, right? Remember that thing? It's going to act like that. The question is it down or up? Why not up? There you go. It can't come up because if it comes up, it would have crossed our x-axis right here somewhere, wouldn't it? And we'd have another x-intercept. So we don't have that, so it must go down. But it's not a line necessarily. So it curves down. Then it's kindergarten, connect the dots. And then go to the next dot, which is up here. And then that vertical, when I try and come out the other side of that dot, that vertical is going to keep forcing me up. I can't go back down because I don't have an x-intercept down there. So it almost looks like a line, but it is curved. You jump over the vertical, you grab your next point, and go out the left side of it, which means I'm going to have to go where? Out the left side is going to have to go which way? Down. So it's going to go down over here, and then up here it's going to connect, and then connect, and then upward, right? I can't go back down. It's either got to go up forever or down forever here. Can't come back down because I'll cross the x-axis. So it's going to look like this. Whoa. Oh, come on. I missed it. It's all right. I just moved the dot. That's our best picture that we can get. So, what do you think? Is it really, really bad, or do you feel like it's reasonable? Reasonable. There are a lot of steps. Yeah. But it's a lot harder than, the polynomial now seems easy. Well, unless you have the synthetic division, because, you have to make that list and all that. But all right, we still have 10 minutes, which means we can get the last type. X squared minus 2x minus 8 over x cubed minus 2x squared. First step, factor. X minus 4, x plus 2 on top. The bottom. What can you do on the bottom? GCF of x squared, and that leaves you with x minus 2, right? Can't go any further than that. Step B, we don't have anything that cancels, right? Nothing cancels. Step C, that's my x-intercepts. What are they? 4 and -2. Those are my x-intercepts. Everyone understand where I'm getting these? Just setting these. That was setting the top to 0, right? Step D, find the verticals. Careful here. 0, good, and 2. Because you can't forget about this one right here. That gives you that 0. Step E. What case do we have here? What's the degree of the numerator? 2. Denominator is 3. So numerator is smaller than denominator. So we are in case 1. And whenever you have case 1, what's your horizontal? Y equals 0, which is the x-axis. Right? I mean, we had y equals -1 earlier, which meant we went down 1. We had y equals a half, which meant we went up 1. The last example, we didn't have 1. And in this example, it's saying y equals 0. That means the x-axis itself. I'm ready to draw. I think I can fit this on here. Okay, x-intercepts were at 4, right? And -2. Verticals were at where? 0 and 2. Okay, so we actually have one of these where it goes through the y-axis, don't we? 0 for vertical. So that's where I'm going to do this like dashed looking thing. Kind of overdoing it there with the dashes, but. Where's my horizontal? So the x-axis, right? So what you do is just at the edge of your x-axis, you draw your dotted lines out each side. Now what? Test points. What test points should we get here? How many will we have? We have 5, right? Sucks to be you. Yeah, I have a low battery. Oh well. Okay, so I'm going to pick a -3. I'm going to pick a -1. And pick a +1, a 3, and a 5. Again, notice how nice that worked out. We had them between each one. Now I'd like to save you the time, or save us the time, okay? I'm just going to tell you what the answers are for these to plug in. No one minds that, right? Okay, f of -3 would give you approximately -0.16. F of -1 is approximately 1.67. Has anyone noticed that they've been changing signs? I don't know if anyone's noticed that. In all the problems we've done so far, every time we did test point, the next point changed signs. Okay, this is an example of one that doesn't do that. Because f of 1 is approximately not, well, it is 9 actually. F of 3, so that didn't change signs right there. F of 3 is approximately -0.56. F of 4, I'm going to put it on the top because I don't want to, or sorry, F of 5, I don't want to block my graph, is approximately 0.1. So at -3, I'm going to put a dot where? -0.16, so just down somewhere, right? At -1, I'm at 1.67, so up somewhere. I'm not real big on how high or how low. What really matters is if you're below or above. That's what really matters at the end of it. At 1, you're at 9, so I'll just put it way up there. And at 3, you're at -0.56. I'm put it down here. And at 5, I was at 0.1, so I was just barely up here. We're almost done. With time to spare, we might have time to spare. Look at that. Okay. The far left point, where do you have to go? Where? Your far left point, right there. Where do I have to go as I draw out the left side?
You have to go up and magnetize towards
Magnetized, yes. It goes towards the magnetic blue line like this. To the right, where does it have to go? Up to connect through the x-axis, or x-intercept. Then continuing through the x-intercept up to the next point. And then that point, the barrier is going to be the next thing in my way, which continues me up forever. Yeah? This next point is the trickiest point here. I'm talking about this point right there. Because to the left, what's in the way? The barrier, right? And to the right, there's a barrier. So to the left, where does it go? If I try and go out the left side, it has to go up or down. Can it go down? No. So it has to go up. And on the right, it can't go down either. It has to go up. So it's almost going to look like a little parabola in here. Although it's not a parabola, it's going to look like one. It's going to be like a little U that's forced into that little space. Jump over the vertical, grab your next point. To the left, it must go down because that vertical is in the way. Must connect through the x-intercept, up to the next point, magnet down to the dot. We're done. Okay, I don't have the homework assignment, but how about I email it to you like I did last time? Is that okay? Sound fair? You have seen it all now. This is it. We're done with rational functions because I've given you an example of each case. When is our test? Let me see.
Are you gonna take roll there?
Is everyone here? Everyone's here? All right.
Red table strong.
Wait, our test is next Thursday? Holy moly. Yeah, so let's be here to review on Tuesday. Now, you may not get the homework for this today because, like I said, I'm leaving straight from here to Austin. But look for it in the next 24 hours. All right?